Mark Erikson, one of Redux contributors, has published another article in his Idiomatic Redux series. The article is called The Tao of Redux, Part 1, Implementation and Intent. It was a great read. Mark has made a considerable effort to study older discussions of Redux issues on GitHub, as well as various posts and comments by Dan Abramov, to tell us about the original ideas, goals, and decisions that emerged from designing Redux. This turned out to be a very thorough and detailed overview. In this podcast, I will indicate the main points of the article. So, let's get going. First of all, Mark debunks a few myths about some of the basic Redux requirements. Let's start by taking a look at the now famous 3 principles of Redux. Single source of truth. The state of your whole application is stored in an object tree within a single store. State is read only. The only way to change the state is to emit an action, an object describing what happened. Changes are made with pure functions. To specify how the state tree is transformed by actions, you write pure reducers. In a very real sense, each one of those statements is a lie. Single source of truth is wrong because, per the Redux FAQ, you don't have to put everything into Redux. The store state doesn't have to be an object, and you don't even have to have a single store. State is read only is wrong because there's nothing that actually prevents the rest of the application from modifying the current state tree. And changes are made by pure functions is wrong because the reducer functions could also mutate the state tree directly or kick off other side effects. These principles aren't fixed rules or literal statements about the implementation of Redux. Rather, they form a statement of intent about how Redux should be used. Moreover, the immutability of the state tree itself is a cornerstone of Redux, as it contains a few smart optimizations that involve a simple comparison of objects by reference. It happens twice. First, in the Redux itself, before any calls to subscribers, and then independently in the React Redux package as a part of the connect method, which also performs a shallow comparison of all current component props with previous props. Redux itself won't break if state is mutated. Redux will just not notify subscribers when the whole state object reference is the same, or connected components won't be re-rendered when particular slice of the state is mutated so it's shallow equal. We also know that action objects should be serializable. In other words, they shouldn't contain symbols, promises, and such. In fact, this is not an actual Redux requirement, but rather a recommendation that is meant to facilitate debugging and is crucial for time-traveled debugger. Redux's primary goal is to make state mutations predictable. Constraints like immutability and serializability largely exist to make those development use cases possible, as well as making it easier for developers to trace data flow and update logic. Redux combines those multiple stores into a single state tree to make debugging, state persistence, and features like undo, redo easier to work with. Intended design and use of Redux was the following. Redux was built as a Flux architecture implementation. State update maintainability is the main priority. Action history should have semantic meaning, meaning that action types should have some kind of meaning and information. The Redux dev tools and other logging utilities display the type field for each dispatched action. If only a single action type is used across the entire codebase, like set data, it will be harder to track down where a particular action was dispatched from, and the history log will be less readable. Redux is intended to introduce functional programming principles. This includes FP basics such as immutability and pure functions and ideas such as composing functions together to achieve a larger task, but not going deep into abstract FP concepts like monads or endofunctors. Redux promotes testable code. Reducer functions should be organized by state slice. Update logic and data flow are explicit. Redux does not contain any magic. Everything is intended to be explicit, clear, and traceable with minimal abstraction. Redux's API should be minimal. The best API is often no API. Redux should be as extensible as possible. This ties in with the minimal API goal. Mark, the author of the article, has certainly dedicated a lot of time to researching and reading back through early issues and discussions. A substantial list of links to the sources is provided at the end of the article. Thank you, Mark, for your effort and your excellent content. Code with React and prosper.